Good morning, good afternoon everyone, and welcome to the first bonus episode of this series on how to make a Web3D Infinite Runner game. In this episode, we're gonna add various improvements to a Hyperspeed game, like a fog or camera shakes. Are you ready? Then let's dive in. Last time, we finished the core features of our game by talking about sounds and music. This concluded the main part of this series of tutorials, and we now have a functioning game. However, there are still lots of little things that we can discuss, which is why I'm going to continue posting a few additional bonus episodes. In this first bonus tutorial, we'll work on various improvements for our game. We'll see how to add some fog in the distance, how to have obstacle collisions trigger a camera shake, how to show little pop-ups when we collect bonuses to better warn the players about the price of the object that they just grabbed, and we're gonna see how to have the game speed up gradually as it progresses. Okay, let's start with the fog. Thanks to 3.js built-ins, it is actually pretty simple to add fog in our scene and have the objects that spawn at the horizon be very dimmed. All we need to do is go to our main.js script, and after we've created the scene, we use 3.js's fog function to directly create a new fog with a given near and far clip planes. As explained in the official docs, this method lets us create a fade effect for all objects that are within a given distance range from the camera. So objects that are closer from the camera than the near plane will not be affected, and similarly, objects that are further away from the camera than the far plane won't be affected either. In our case, given the dimensions of our grid, we can use something like 120 and 160 for the near and far clip planes to only fade the just spawned objects. However, you might notice that at this point, the objects are fading, but not the grid itself. So the grid is still solid white, even at the horizon. And that's because remember that our grid is a static object, which position is fixed at 0. In other words, it is far closer to the camera than the 120 near plane we just defined. To fix this, we'll once again need to improve our grid shader. The idea is basically that we need to take our vec color, but multiply it by a function that decreases as we look further away in front of us, and so it will gradually go down to a black color. So first, let's move our color declaration after we've computed our new pos.z variable, and then let's use this variable but normalize it using the grid limit, so that's 200. Also, don't forget that the z-axis is pointing backwards from us, so we need to take the opposite of this value. So if I compute this coefficient and apply it to my color, you see that we now have a fading gradient, except it's in the wrong direction. So for now, the grid is getting darker and darker as I get closer to my spaceship, which is the reverse from what I want. But all I need to do is actually subtract this value to 1, so that I get the inverse. And also note that you can play around with the denominator to have the gradient spread more or less. So a higher value in here will constrain the gradient to the horizon, while a smaller value will make it come closer to our position. Okay, we now have a nice little fog effect. The second improvement I want to make is add some camera shakes whenever I hit an obstacle. This will reinforce the collision effect because for now the player is just warned by a sound, but it's not that impressive visually. So to begin with, let's go to our game class and create a new function called shake camera that will call from our check collisions method if we hit an obstacle. In this function, I'll basically want to do a series of small lerps from the camera position to a slightly offset position pretty quickly, so that it feels like the camera is just jumping around for a little while, and then I'll finally reset the camera to its original position to restore the normal gameplay. This means that first we need to bake and send this initial position to the function. Let's add this parameter and pass it in when we call the method from our checkCollisions function. Note that we can't just pass the this.cameraPosition because this would pass it by reference and not by value, meaning that the script would actually grab the latest value for this variable when it needs it instead of the one that it had when we called the function. By passing in an object like this, we make sure that we pass the position the camera had at the beginning of the shake. Now, back in our shake camera, we know that we want to make a series of loops. This means that we will be calling this shake camera function recursively for a given number of times, and then when we've finished our series of small jumps, we'll exit the shake mode and reset the camera. To do this, let's first define a new parameter, remaining shakes, that is by default set to 3. Then let's create a new looped object that in its onFinishHook checks to see if there are still some remaining shakes to perform. If there are, it will recall the shake function with one less shake, else it will reset the camera position. Now, the loop we want to compute is a loop on the offset. We're gonna loop an object with two keys, x and y, and have those values go from 0 to a random float in the minus 0.25, 0.25 range. As usual, those are values that I've tested and I think work well for my game, but feel free to adapt those to your needs. We'll see in just a second how to update our handmade loop module to handle objects instead of just single float values. Just before we do that, however, we need to use the onUpdate hook of the looped object to update the position of the camera. So we'll simply record the start position at the very beginning of the function. That's the position that the camera has when we have an offset of 0. And then in the onUpdate, we'll add the looped offset to this position. And of course, we also need to assign this loop object to an instance variable, so something like this.cameraLoop, for example, and declare it in the reset function so that we can change its current time delta in the update function, just like the rotate loop we had before. Now we just have to jump to our loop.js file, and in the update method, we're going to check whether we're working with a simple number, like what we had for the ship rotation, for example, or with an object. If we have an object, then we'll loop all the keys inside. Note that we expect the from and to objects to have matching keys to perform this computation. So here, for example, my from and to objects will both have the x and y keys. If you save this, you'll see that now when you hit an obstacle, the camera jitters a bit around before resetting to its initial position. In this third part, we're gonna see how to add pop-ups when we pick bonuses up. This will help the player evaluate how much score points this bonus was worth and add some dynamism to the scene. Overall, the technique is just to create a temporary div in our DOM that has a little animation to float upwards and disappear gradually. Adding this div is pretty easy to do in JavaScript thanks to some built-in DOM functions. So I'll just create a new util method, create score popup, still in my game class, that takes in the score value to display, and I'll call it from my checkCollisions function whenever I collide with the bonus. Then, in this method, I will create a new DOM element using document.createElement. In here, I need to pass in the tag name of the HTML element to make. So I'll just be creating a div for now. And then I can set the inner text and a specific class for this new element. Then I append it to the document, so this is to push it to the DOM tree, and I set a little timeout to remove it from the DOM after a second, so that will be when its animation is finished, it will be automatically removed. We'll see in more detail in the third bonus episode how to make dynamic elements in HTML thanks to JavaScript. This is just a little introduction to this mechanism. Okay, now let's go to our CSS file and add some animations to the objects that use this class. So first, we want this pop-up to be roughly in the center of the screen. For this, we can use absolute positioning and use the left parameter along with a small translate. So this transform property basically recenters the object so that its pivot point is now in the middle of the label and not in the top left corner. But I won't be setting the top value directly. Instead, I said that this core popup class uses an animation that controls both the top value and the opacity of the HTML element. More precisely, I'll define two keyframes at 0 and 100%, meaning the very beginning and the very end of the animation. And I'll say that the top value goes from 33% to 25%, so it makes it move up a little. And I'll also say that the opacity fades from 1 to 0. I need to make sure that this animation plays only once, so I'll pass the animation iteration count property and set it to 1. And now we can wrap this up by increasing the font size and setting the color to white. Now if you run your game, you see that when you go over a bonus, there's a little pop-up in the middle of the screen that tells you the price of the bonus that you just grabbed. Finally, let's make our game slowly speed up as it progresses. This is pretty common in arcade-style games. The game in itself doesn't change much throughout the session, but it gets harder and harder, either because there are more enemies or because it just gets faster. Here, to have the game accelerate, we actually only need 2 lines of code. We just have to go to our update grid method and at the very top, add a small increment to our speedz value every turn. We also have to re-update this value in the grid shader so that the grid movement is consistent with the object's parent anchors. And this way we're gonna slowly accelerate as the game progresses. But be careful though, don't put too high a value here for the increment. Since this is happening every turn, if you put a large value in here, the game will speed up very, very rapidly, and so the game will basically be unplayable after just a few seconds. Alright, today we've made various little improvements to our game, so we now have some fog, camera shakes, bonus pop-ups, and even a slight speed up of the game every turn. Next time, the second bonus episode will be about debugging. We will see how to show a little debugging stats panel in our game to easily inspect the FPS and memory consumption of our app. So I hope you enjoyed this episode, and I'll see you soon in the next one.